Travis Spencer. I'm the CEO of Curity. I'm also the founder of Nordic APIs. And for those of you who don't know Curity, Curity is an API access management company helping to secure APIs by authenticating and identifying users, wrapping all of that answer of that question of who you are in a security token so you can provide it to your API and your API can decide if you should have access to those resources or capabilities. But that's not what I'm here to talk to you about today. What I'm here to talk to you about is decentralized identity and how it will change everything, even your APIs. It's a really exciting time in digital identity because we're facing a paradigm shift. We're shifting from the way we've been recognizing and identifying people online to an entirely new model and an entirely new way of doing that. Till now, we've been centralizing all of those identity representations, all those personas, all those records of end users in very large databases. The biggest ones by the big tech companies, but even in smaller examples of that, they're all stored in a centralized repository, and all these different applications and websites and web services will end up connecting to that central storage location. And what we're shifting to in this paradigm, this new paradigm, is to a decentralized manifestation where all of those identities can be used and consumed by different applications without a central hub, if you will. And so in order to understand this better, I'd like to first look at the classic approach, and then I'll show you the new approach, which is actually quite intuitive. I would even say more intuitive than this way that we've been doing it. So in the way we have it now, in a federated kind of approach, you'll have someone requesting access to some sort of website, like a bank. And instead of the bank doing any of the authentication and login, it will redirect you to some sort of identity provider, like a government. And at that authority, that government agency, you'll identify yourself by providing some sort of credential that central hub will recognize and know, that shared secret of some kind of form, and then it will turn around and issue a token and send that back to the bank or what's called a relying party. So in this case, that relying party or the bank doesn't do any of the authentication. It relies upon that central authority to do that for you. So this is the federated approach. What we're moving to now is a decentralized approach, so that sort of topology where there is no hub in the middle. And to understand this, let's use a real-world way of looking at digital identity or non-digital identity. So in our day-to-day lives, very often we get some sort of credential, some sort of identity document or proof of our identity from a government or some other kind of authority. We get a passport, for example. And then we can go to different places like border control or like a bank, and when they need to identify us, we can just present our credential, we can present that passport, and that bank or other entity will trust the issuer of that identity document and not have to make any kind of direct connection to that authority, but just accept your passport and let you open a banking account, or accept your passport and let you through the border. So this is how identity works in the real world, and what we're shifting to in this new paradigm is to do this in the digital world. Okay? So in the digital world, we'll have an issuer, and that issuer will create credentials, just like in the real world, and this digital credential will be stored in a wallet, a digital wallet. And that wallet then, whenever you go to different websites, different applications, you'll be able to present some sort of credential from your wallet in order to identify yourself. So that application that needs identity information would be called a verifier. So it will verify that credential, and it will accept it because it trusts the issuer, just like the bank trusted the government to have done what it needed to do to give you that passport. See the parallels there? So in this, there's no direct connection to the issuer ever. It's just the wallet presenting it to the verifier. A new actor in this new paradigm is the wallet, so I just want to double click on that a little bit. The wallet is some sort of application that's storing all of these credentials. And these credentials often are called verifiable credentials because they can be verified digitally and electronically. And the wallet has these verifiable credentials, and there are three kinds of wallets. There will either be a self-contained wallet, which is a wallet unto itself, an embedded wallet, which is a wallet that is embedded in an application with other kinds of functionality. And then there's a roaming wallet. And a roaming wallet is almost like some sort of escrow service or escrow agent that has all of your verifiable credentials. So if you lose your mobile phone where you have your wallet, you'll still be able to have access to all your verifiable credentials. Whereas if you use the self-contained or the embedded, if you have that on a mobile phone and you lose that mobile phone, all your credentials are gone. So the roaming is kind of forming that escrow for you, but then you have it somewhere, and so there's security implications to that, but also user experience benefits. So these are the different kinds of wallets that you'll see, and this is a new actor in the decentralized identity paradigm, so I just wanted to highlight that and show that. And in time, there will be a handful of self-contained wallets, and they'll be by the big tech kind of companies, but the embedded wallets, those will probably be quite numerous, and so I think that most online banks, they'll have embedded wallet capabilities. A lot of governments, with their different citizen services, they'll embed wallet capabilities perhaps. And I think there'll be quite a few roaming wallets for those, protecting against that situation where you might lose your phone. And those could actually be provided by the same people who are providing the self-contained wallets. There's a lot of benefits to this new approach to doing digital identity. One is that the user is in control of their own data. So instead of housing it in a big repository and that authority or identity provider being the one who maintains that, the user is in more control over what data they have and to who they release it and so forth. It also means that organizations don't need to have as much PII or personally identifiable information. So the way that the protocols underneath work, it allows the user to selectively release certain identity information. So instead of having to give your whole passport per se, you could just have some piece of information from the passport that would be enough for the application you're accessing. So you're reducing the amount of PII that you're sharing with the services that you're accessing. Another is that you have a universal approach to handling identifiers. You might hear of this acronym DID for Decentralized Identities or identifiers. So that's another benefit of this new paradigm. And this isn't exhaustive, but this is some to give you a sense. But because this is an API show, I really want to highlight the implications or the uses of this new approach with APIs, and also in a lot of the scenarios and use cases I'll describe in a bit, they're almost all API driven. So it's important for us to see that this is actually bringing a lot of benefits to this community. But the first step in adopting this new paradigm is that you need to have a token-based architecture. So some of the speakers yesterday gave you homework. This is also some homework that you need to do when you leave here, is to make sure that all of your APIs are accepting tokens and that you're using standard protocols to obtain those tokens. If you're not doing that, it's going to be a much bigger shift in migration for you into this new paradigm. So what you should do is you should actually use an OAuth or an OpenID Connect server to issue those tokens to your applications and then use those tokens within your APIs. Because then what will happen is when users are accessing your website, instead of your website having to do anything with this new paradigm of identity, they'll just continue to talk to your identity server and say, you know, I need this user to be logged in, I need them to be authenticated. You don't really, as the app website, care or know that it's using the federated approach or this new decentralized approach. The identity server will talk to the wallet. The wallet will present different verifiable credentials that could satisfy the request. And once that verifiable credential is provided to the identity server, a token is issued. Because you did your homework and you adopted that token-based architecture, your website's unaffected by that. It has the token and can call your APIs, and your APIs can perform access control with that. So this is how we can pivot into this new paradigm in a gentle manner. So now to help us see all of the amazing things that we could do with this, I wanted to kind of share with you some of my imaginings of how decentralized identity could open up all sorts of new use cases. And these are very fluffy, I'll admit, but we can talk about some of the details during the break. So in the first scenario, which I think is pretty easy to like wrap your mind around, because maybe you even had some of these experiences already but not using this exact technology, is a scenario of a boarding pass, where you have a traveler like Taylor. She comes to the airport and she needs to get her boarding pass, and in order to do that, she'll have her wallet, and she has that on her mobile phone, and when presented at the kiosk, she can share, probably through like Bluetooth Low Energy, her credential to that kiosk directly. So there's no connection to any sort of central authority there. She can share her ticket, and it actually then will load her wallet with a new credential, which is a boarding pass that will last for the next few hours while she gets access to the flight. So once she has that boarding pass, she can also use that when she goes to the lounge, because she's a frequent flyer there. As today with the paper, she's able to present her wallet, and the boarding pass credential comes up because that's the kind of credential that's being asked for. She gets into the lounge. She's also then able to use that to get different amenities like fresh coffee, using her frequent flyer miles maybe, and then also getting some discounts for things when she's traveling and enjoys her vacation. A lot of APIs in that behind the scenes, as I'm sure you can imagine. Another is around onboarding. So imagine a new employee, Alex, and Alex is coming to work for the first time, and he has in his wallet various kinds of identity, various kinds of credentials. Maybe he has his passport loaded in his wallet, his driver's license, and some sort of electronic EID. And his new employer will accept any of those kinds of identities, and so he can pick which one that he wants to release, and the data of that from each of those identities, or one particular identity, that is enough to satisfy the employer's requirements. So maybe his first name, his last name, his address, social security number, those kind of things, but nothing more than what the employer needs. So he's able to select the credential and the data from that credential, release it, create a new account at his new employer. He's welcomed aboard, he's ready to work, and he starts off at his new job. So this is an example of what we can do with decentralized identity, and in this note that there's no connection to any sort of government to use that passport. There's no connection to the driver's license authority, any of that. It's just directly between Alex and his new employer. And this is the paradigm shift. Think of the APIs also in that. Another example is a library card. So imagine a student named Kim, and she is attending university, and she goes to the library there in her city, and she has in her wallet various credentials. One of them is her public library card, and another is her university student body card. And she can check out different kinds of books. One might be public books, and another might be university textbooks. So when she gets there at checkout, if she's just getting a copy of War and Peace, she can use either credential. But if she's checking out, her whatever she's studying for, her textbooks, she needs to use her university credential. And so when she uses the right credential, she'll get access to those different kinds of books. And so here you can also start to see some examples of how we can do access control with those different kinds of credentials to prevent the checkout of the wrong kind of book with the wrong kind of credential. Making sense? Here's a really fun example. Imagine a person named Danny. He's got a new fandangled car that has all this high tech in it, and one of the new features of this drive software on his car is that he can only start it if he has a verifiable credential. And that verifiable credential proves that he is licensed to drive. So he has that in his phone, say. So when he gets into the car, his phone is in his pocket, or he puts it on the charger, and the car, in order to start, asks him from his wallet, please present some sort of credential that proves that you can drive. He selects his driver's license, says, remember this for next time, and the car starts. And maybe sometimes he doesn't bring his phone, but he has his watch. So similar there, he's like, just goes, shares his credential, the car starts. It could even be in the key, right? So those keys are pretty fancy sometimes, and that could even have an embedded wallet inside of it, and the credential could then be tied to the key, so Danny could even loan his car to other people. You could also imagine a scenario, because in some places, in order to teach someone how to drive, you have to go through a certain training to say that you can teach this new pupil how to drive. That could be a credential. So I went through the training, I got the credential. The young driver also needs to have a credential, which is like a learner's permit. And so the new driver has a phone, it has their learner's permit. Danny has in his wallet now the training certification, and the car could be so smart as to know that when the 15-year-old pushes start on the ignition, it sees that you have the learner's permit, but is the trainer with you? So it might prompt the trainer also for a credential to say, yes, I am trained as a trainer, and then the car will start. So a lot of things that we can do with verifiable credentials, and none of this goes back to any sort of central authority. Somewhat similar, but different to the car scenario is heavy machinery. So you could imagine Andrew, who's a forklift driver. He has gone through certain certifications, training, he has a safety record. All of those could be credentials in his wallet. That wallet could be maybe on like a badge, like a employee badge, but it could be also a smartphone or something else. But when Andrew goes and tries to start a forklift, then the forklift itself might not start unless he has that safety record, driver's license, or forklift license, employment at that particular company. All those kind of credentials could be provided before the forklift starts. Even if that sounds far-fetched to have all this computerized mechanisms in a forklift, you could certainly more easily imagine like some sort of barrier or area where the forklifts are, and having that verifiable credential required in order to enter there before you can get the forklift out and start it up. I think that's not at all far-fetched. Here's another fun scenario, is a house key. So imagining access to some sort of home. Imagine a person like Jane who has a door, and in order to enter the door, she has a credential in her phone, in her wallet, that says she's the owner of that home. And so maybe she actually created this credential, maybe she got it from the bank as a part of the loan for it, or from the previous owner. There could be lots of ways of obtaining that credential. But by hook or by crook, when coming to the door, it presents her with a challenge. She uses the credential in her wallet to prove that she lives there. The door opens. And then you could also imagine Jane has children, and those children also need a credential then to get in. Those kids could load up that credential in their smartwatches and be able to use that to get into the door and, after school. You could also imagine that Jane has a cat, and there's a pet door in the back, and in order for the cat to get in, it has like a little GPS locator, and also on that GPS locator it could have an embedded wallet that will implicitly then, without any interaction, challenge the cat, and when it has that right credential and is not a porcupine or something, it is able to come in. You could also imagine with these verifiable credentials that Jane's going on vacation. And when she goes on vacation, she asks her neighbor to water the plants and is able to give a temporary credential to her neighbor so that the neighbor can come in maybe to the whole house or at least parts of the house in order to do that favor for Jane. So a lot of things that we can do with verifiable credentials, and no connections to any central authorities. It's all API driven, using security tokens like we talked about at the beginning. Lots and lots of other examples. I'll just share some of my imaginings quickly. Imagine a casino where you have to be 18 years old. You could have a credential on your smartwatch before you're able to start the gambling machine there, or to be able to place a bet or to get poker chips or what have you. All of those could require a verifiable credential that you would have to present in order to entertain yourself in that way. You could also imagine that maybe you have a propensity toward addiction, and your support group has helped you out by making sure that you enjoy this, but within safe limits. And so you could have another credential that says how much you can spend, when you can spend, how often you can do it. These sort of things could end up being a credential, and getting those chips or playing the slots could also verify that credential before letting you entertain yourself in that way. So a lot of exciting possibilities, I think, in entertainment and gambling in particular with verifiable credentials. Hotel room, I think, is a pretty easy use case for all of us to imagine. When we checked in here at the hotel or the other one, we could have gotten a verifiable credential loaded into our wallet on our smartphones and used that in order to get into the gym, into our room, maybe even appear into the event area. So the verifiable credentials and using those to access enclosed spaces, like with the Jane's house or the heavy machinery or those kind of things, can also be extended to things like hotel rooms for sure. Another example that I can imagine is insurance. So maybe you get some sort of insurance premium that could end up being a verifiable credential that you load into your wallet. And if we go back to our car example, maybe in order for that car to start, it also wants to make sure that you have some sort of verifiable credential proving that you have insurance to cover an accident while you're driving. So an insurance premium being loaded into your wallet, being used in a car, being used in the forklift example, lots of different things there that we could use that to know if the required insurance is available. A few more examples. Imagine a house deed. You go to the bank and you pay off your house. Congratulations, that's really great. Here's a verifiable credential. You now own this house, and you can maybe put that in one of those escrow services, right? Because you would definitely not want to lose that credential, and it's going to have to last for several decades. Maybe you won't even want to give this to someone in the future if you pass on. That verifiable credential proves that you own the house. It could also tie up to Jane's access to the door. So if she has that house deed verifiable credential, she could create a new credential that she actually should be allowed access into it and able to provide other people with verifiable credentials that let them into the home. The will then is a natural extension of that, where the beneficiaries, the subject of the will, maybe the attorneys of record could all have their identities formed into a verifiable credential together with the conditions and the text of the will, and that verifiable credential could be sealed and only open at a certain time and in certain conditions, like proof of death, and then read and acted on. So will could be a verifiable credential. Power of attorney could as well. As a business owner, I can tell you I hate power of attorney. It's what's happening with it. You know, where is it being used? I don't know any of these kind of things. It's just like, sure, go and handle all this for the business in the business's name. It would be a lot more comfortable if it was a verifiable credential, and that attorney that has that, we could see the rights, we could delegate those certain rights as rights in the verifiable credential, so that when the attorney goes down to the courthouse to file some papers or acting with a trademark authority or what have you, they have to provide this verifiable credential, and those authorities can check in there that that is actually a delegated right that the business has given to that attorney or advocate. So I think helps a lot in some of those kind of ways. Hopefully you're getting a sense, but also keeping in mind that this is API driven and there's no central authority. Just a few more examples, not to belabor the point, but a ship captain or a pilot, a couple summers ago, took the family to the Columbia River turns out the Columbia River Bar there in Oregon and Washington is one of the most dangerous bars to pass. So a ship captain's not allowed to go over that bar. They have to bring in a pilot that knows the area, knows the conditions, and that pilot is specialized for working in that area. So the pilot could have a credential, and in order to take control of the ship, might have to prove that they have that credential, and then they're able to begin piloting the ship across the bar. Machine repair. A lot of these machines that do different things in manufacturing are quite expensive. And having someone who's uncertified, untrained, has a bad safety record or quality record, having them operate on that machine can end up being quite costly. So wrapping that up in a credential that they have in a wallet or some sort of employee badge or other kind of embedded wallet could be quite important to make sure that they're not even able to open the machine to start doing repairs on it or accessing diagnostic systems on that machine. A pretty obvious example, which I think will be my last here, is a diploma. After you graduate, getting that as a verifiable credential. Maybe on the diploma you're given on stage, it has a QR code. You scan that with your wallet. It takes you to some sort of website where they issue you a new credential. You load that in your wallet. So then, like Andrew on that first day at work, he's not only providing his EID or his driver's license, but he could also be providing his credentials showing that he is having the right education, or maybe beforehand, before Andrew was even hired, when he was applying, he would have had to share that credential. If you want to learn more about decentralized identity and all the amazing things that it can do for us, here's a few websites. You can also take a picture or scan those QR codes, which will take you to those three websites, giving you an overview of decentralized identity, verifiable credentials, and this whole new paradigm that I've been talking with you about. So that's all I have for you today. Thank you very much. Hope you enjoyed it.